I just want to answer a few questions that have come in about the V1. I will try and do full tutorials at some point, but they're an incredibly time-consuming thing to make. But I know people are waiting, so I need to look at the thumb, I need to look at the wrist, and I need to look at the electronics. So I'm just going to do a quick run through now, and if you have more questions, stick them in the comments, and maybe this is a better way of doing it, and I can just keep putting out short, unedited videos which take just as long as it takes to film them. So looking at the thumb first, the questions seem to arise mainly about the PTFE. And you can see when you put the wrist together, and that one I did do a video on, the PTFE, there are 8 of them, which are going to have to come through the wrist. And back here in the forearm, they come from 2 main places. They come from through this centre, and they go back to the servos here, and they come through the sides, and they go to the servos here. The way that I set it up is that the 4 at the front take the 2 on each side, so the 4 PTFEs, and they can run forwards and then through and into the palm bones, and they end up down here. And the action of the servos moving and of the wrist moving is to push those PTFEs up. So this is not a Bowden cable. A Bowden cable is like a bicycle brake cable. And in a Bowden cable, the force is taken by the outer. I don't do that on this one. I use the force in the fingers to pull at the wrist. And that has advantages and disadvantages. You can choose to do that how you want. So those are the 4 that come from here. They go up to the end. There are 4 which pass. They're quite awkward to put in. And they come through this centre. And they emerge here. And I've made some cutouts on the newer CAD. But before I used to have to do quite a bit of drilling. And those 4 are going to emerge here. And there are 4 of them which go to the thumb. And you just do it the same as the fingers. There's a connection here now included in the CAD. There's one here, there's one here. In fact, the new CAD. Yes, in fact, you can see on the new CAD. There's one here, there's one here, and now I've added this tendon hanger. So that one passes up, it goes under the thumb, it's one of these 4, and you're going to wrap it round there, poke it through the hole, and that will give you that attachment point. I've also added the hook, or maybe it's a pin on this. I thought there was a hook actually, so all right, do it with a pin or maybe a screw, but it looks like a screw hole to me. So that will give you the attachment point for that. And that brings us on to the thumb. All right, so that's the wrist, those are the PTFEs. Now for the thumb. Those 4, one passes through the middle of the basal joint, which goes that way around, and that is the flexor, which will make the last 2 joints contract. Not sure which one it is. Anyway, you also have the 2 knuckle ones. One goes here, and one goes to that new hanger, which is there. And then finally on the V1, you have a rotation. You can directly drive the rotation. And I kind of changed that now on the V2, but that's by the by. And that goes up to this top point, which is just there. And in the thumb itself, you'll see, I've got a variety of ways. It's either, I think it's all pins now, actually. It's a new thumb. Yeah, it looks like it's all pins. So you push a pin in there, you push a pin in there, and that will give you the anchor points. One for a band, which goes across to the to a tendon support hanger, and the other end connects into that recess in the thumb. Just goes in there, pin goes in there. And then also in that corner, there's another pin which is going to take the tendon for rotation. So missing, there should be a bearing there. So it looks correct. Let's put that all together. Okay, so those are the 4 tendons of the thumb. They are the 4 center PTFEs, 1, 2, 3, and 4, 2 knuckles, 1 flexor through the middle, 1 rotator. And that pulls in opposition to a spring there. And then finally, there's another extender, just like the fingers, and that goes back to here. bands, and you can see how these bands are just falling to pieces now, hence moving over to steel springs. So that is how you assemble the thumb. I think all the CAD is complete for that. Now, if there are problems with it, let me know. I will look at adjusting, as always. Okay, and then the final thing, once you've built everything mechanically, of course, you're going to have to connect it up electrically. And if you have done everything correctly and remember to extend this one servo, you will have just enough length on these cables to poke them through the hole on the back of the forearm. It will look like that at this stage. Now, these are legacy servo wires, and so all of these are the same. They take a pulse width modulation signal, and pulse width modulation just means that you get a square wave. Just do a quick drawing for you. So in pulse width modulation, you have a signal which looks something like that. And typically this varies by not a huge amount. This might be down to 0.05 and up to 0.15. So, you know, like 10% variation. And the width of those relative to the width of this gives you a signal. And this was done because before digital electronics, it was done with capacitors and resistors, and this forms a resistor capacitive circuit, which is a timing circuit. For the servos, which you can also use, which are the serial servos, which is this kind of thing, you actually get a very similar waveform, except instead of having a fixed number of pulses, i.e. one pulse per cycle, you can have, depending on how many bits are in your byte, up to 8, I guess it must be, and then probably another one which is called a parity bit, but you don't need to get into that. When you run serial, on the whole, it's very simple from the user's point of view, and when it works, it just works. I digress. So standard servos, which what these are, is pulse width modulation, and that means that each of these yellow cables has to go to its own pinout. This is an Arduino Mega, which is very useful because it has 4 serial ports and it has a large number of digital IOs. So if you look up the pinout diagrams, you'll find labels which correspond to each of these holes. And for the PWM servos in the hand, the 16, which drive the fingers and the thumb, then each yellow wire has to connect to one of these. And the decision about which one you use is largely dominated, or is certainly influenced, by the length of these cables and how you can resist them breaking. Because when you solder, you change the copper and it becomes quite brittle. So you can see a couple here have broken. And what I advise to do, in fact, is to leave as much cable as possible, loop it beyond where you want to solder, and then go back. Soldering itself is tricky. Well, it's not tricky. It can be a bit annoying. And I've made a video, in fact, I can post that as well. The one tip I would suggest very strongly that you use, because it makes life much easier, if I can find it, anyway, is to just use blue tack. If you just put, when you put your wire through, and when you put a blob of blue tack, it'll hold it in place, and then you can solder it from the back. The other consideration as to which pins to use is if you're going to use a third-party software like Synthium, then only certain pins can be the servo outputs. Actually, thinking about that must be true for all of it. Check the pinout diagrams. It will tell you which of these pins can be used for generating PWM signals for servos. And also look around a little bit, because it's not always that obvious, but you will find forums where people list out which ones you can definitely use. And if I get the time, I will do that myself, or maybe someone can do that and post that in the comments. That would be great. Anyway, that's what you do with the electrical. You bring all of the yellow up, each of these yellow ones, and you connect them to the pins, which you have checked can be used for servo signals. On this particular board, I've also got an S-bus coming in, and because I use serial servos for the wrist, I've got a serial going out, which is this one, and I've got an additional serial coming in, which is this XB, and that's why I need the 4 channels. 4 channels on a Arduino Mega. One goes through a USB and connects to your PC, which means you can debug, and that's very important. If you can't access information from this and something goes wrong, you're just in the dark. So that's going to be serial 0, serial 1, 2 and 3 are going to be this XB, that TTO linker board which goes off to the VTEC servos, and this S-bus in. You don't have to do all of those. If you're just doing a standard hand with PWM servos, and for the wrist you can also use PWM servos, then you only need to have some way of putting information into that, and frankly just plugging in a USB from Synthium will do the job. Synthium produce a software called ARC, and that's very useful in fact, because you can, as soon as everything's running, you can just connect it to all sorts of stuff, including Vision and ChatGPT, and I'm just really starting to learn that system, but it's very promising. Again, I digress. So that's the basic system. The slightly more advanced one is that you're going to use serial servos in the wrists, because that way you're going to get a greater range of motion and you'll get information like temperature, so you can tell if you're going to start to burn things out. And frankly, that's what you're going to have to move up to at some point anyway. The V1 is pretty, but it's not particularly capable. I think for doing gestures, sign language, all that kind of stuff, great, it'll run for a good long while. But if you can start picking things up, and pretty quickly you're going to burn these servos out. IoT did do an improved board where it measures the current, so you can check if you're just sitting there pulling a lot of juice. The problem with legacy PWM servos is they are quite prone to burning out. So moving up to serial makes a lot of sense. If you are doing that, then in addition to these yellow servo PWM lines, you're going to have, I've used green and yellow, a couple of serial lines, and they will connect into the top of that linker. And which one goes to which? Worth spending a bit of time getting your TX and your RX right. I can maybe put that in the comments as a note, because off the top of my head I can't remember and I always get it wrong. But depending on which way you're looking and your perspective, the in and the outs and the RX and the TX are going to swap over. So I don't want to say that in case I get it wrong. Anyway, but what happens is that those 2 signal lines, also the ground connection, you must connect your ground loops, otherwise you won't get relative signal, and power, but I don't think it's actually necessary, because the power comes from somewhere else. But the serial out from the Arduino, which is getting serial in from the XB or from the computer through the USB, will go to the TT linker board. That is basically just a voltage converter, and it shifts the signal coming out of this to something that the servos are happy to read. This plugs into the servos themselves, and in fact that's one which is missing from here. This would be the wrist servo, and in fact you can see I've split the wires there. So there's going to be one, this comes out of the board. One signal goes off to the rotation servo, which would normally sit there, and the other 2 signals go off to the 2 wrist servos if you're using serial servos. If you're using PWM servos, just the same as normal. And then in the Arduino code, you'll see that there's code to send serial out over that. You'll have to tune your servos, and I've done that in other videos. You've got to change the IDs. And then that way, depending on what you want to send, you can make the wrist move, you can make the fingers move, and everything in theory should work. In practice, generally what happens is there's a lot of looking at it and going, why is it not working? Or why is it not working anymore? So the one very strong advice I would give you is to get the simplest thing, a single degree, get anything working, and then head towards where you want to get, changing only one thing at a time. So always make sure that all the things you think are working. Check voltages, make sure the servos work, plug them in, make sure it still works. And then when you start changing code, and this is particularly when it gets difficult, when you start changing code, it's very easy to make changes to code which have weird effects on hardware. If you change a bunch of stuff simultaneously and it stops working, it's just going to take a long time to work out why, unless you get lucky. And that just makes it inefficient. So that is my advice to you. 2 things that really matter with robotics. for wiring and making sure it doesn't break. And that's another good reason to move over to the serial servos in the V2, because there's just less wiring. And debugging, getting stuff to work that used to work and keeping it working. Like the early days of computers, early valve computers, there was always a lot of reliability issues. I think very soon we will go through that phase because we have the technology to do it, and that's one of the reasons why robots are suddenly going to be everywhere. Anyway, I hope that helps. More questions, stick them in the comments. I will just reply like this because I can do that, and eventually when I have the time I will do a full set of tutorials. Assuming that people actually do want to build the V1. The V2 will be coming soon, and I think it's going to be much easier, much more capable, and I'm excited to share that with you soon actually. So working on that, and good luck. Let me know how you get on. Hope that helps.